I'm going to take you through some past paper questions that I want you to learn. So you go through all of these ones and you learn them. So this one, it says find the size of the angle that the line joining the points A, 0, -1, and B, 3√32 make with the positive direction of the x-axis. So as soon as you see the positive direction of the x-axis, then the first thing you're going to write down is gradient is equal to tan theta. That's code for you to write that down. Now we want to find the size of the angle, so I'm just going to write this round the other way. So tan theta, we're going to have to find that first, and that's equal to the gradient. Now we can work out the gradient. We've got 2 points, so we'll call that x1, we'll call that y1, we'll call that x2, and we'll call that y2. So basically back to National 5, the gradient is equal to y2 minus y1 divided by x2 minus x1. We're going to sub those numbers in. So y2 is 2 and y1 is -1, so it's minus 1, so it's going to be +1, divided by x2 minus x1 is 3√3 minus 0. So when I tidy that up, I get 3 divided by 3√3. Now we've got to simplify. So when we simplify that, we divide top and bottom by 3. 3 into 3 goes once. 3 into 3 goes once. So that's equal to 1/√3. So now we know that tan theta is equal to 1/√3. Now this is a non-calculator paper. So normally we would do tan theta, we want to shift that away, so we would say that theta is equal to tan to the -1 of 1 divided by √3, but we don't have a calculator to use for this, so we've got to think about our exact values. Now when you start a paper, you're going to draw your exact value triangles at the front of your information sheet. I'll draw one down here for you just now, just to show you. So that started off as an equilateral triangle, so that angle was 60 degrees. Each side was 2, I halved that one to make that 1. Using Pythagoras, that's going to be 2 squared, which is 4, minus 1 squared, which is 1, so it's going to be 4 minus 1 is 3, and we take the square root. Now we halved the triangle down the middle, so that wee bit up there is 30. So I want to know what's the exact value, what angle is going to give me 1/√3. Now tan is opposite over adjacent, so there's opposite, there's adjacent, so the angle has got to be 30 degrees. So theta is equal to 30 degrees. So that's bringing in your tan theta, but it's also bringing in your exact values. Okay, so that's why it's important that you get these wee triangles clear in your head and you learn them. Right, I'm now going to do a few past papers just to give you an idea of what the standard is that you're asked. So 2023 paper 1, so this is non-calculator. Okay, so you still get your non-calculator paper. Right, so it says P and Q are the points -2, 6 and 10, 0. Find the equation of the perpendicular bisector of PQ. So what we do is just draw a line down that represents PQ. I'm just going to draw it horizontally. Although it wouldn't look like that if you plotted it down. It would be at an angle, but it doesn't really matter because it's just a wee diagram to represent that. So P is the point -2, 6 and Q is the point 10, 0. Important thing here is we want the perpendicular bisector. That's one of the 3 lines that we've got to be able to find the equation of. So what does perpendicular bisector mean? Perpendicular means a line that's meeting this line PQ at right angles, and if you bisect something, you cut it in half. So the perpendicular bisector of PQ is the line that cuts it right down the middle, and it cuts it at 90 degrees. So that's basically a wee representation of your perpendicular bisector. Now we want to find the equation of that. We've got to find the equation of the perpendicular bisector. It's a line, so it's the equation of a line. So we need 2 things. I need a point and I need the gradient. I know nothing on that line just now, but I can work out a point because I know that's the midpoint. So we'll work out the coordinates of that to start with. So to get the midpoint, we add the 2 x's together and divide by 2. So we've got -2 plus 10 divided by 2. That's your x coordinate. Your y coordinate is going to be 6 plus 0 divided by 2. Okay, so that's the working shown for that. We'll now work out the coordinates of it. So that's the same as 10 take away 2 is 8. 8 divided by 2 is 4. And 6 plus nothing is still 6. 6 divided by 2 is 3. So I now know that this point M is 4, 3. So to get the equation of the line, I know a point in the line. I still don't know the gradient, and I don't have enough information about this perpendicular bisector to find the gradient. But the clue is it's perpendicular to PQ. So if we can work out the gradient of PQ, to find the perpendicular gradient, we flip and change the sign. So we start off and we say the gradient of PQ, so M, PQ. We've got our 2 points, so P was a point minus 2, 6, I'll rewrite them, and Q was a point 10, 0. We'll call that first point, point 1, so that then becomes x1, and that will be y1, that will be x2, and that will be y2. So therefore, our gradient, MPQ, we're going to use the wee formula that you learned in 4th year, maybe even 3rd year. We've got y2 minus y1 divided by x2 minus x1. So y2 minus y1 is 0 minus 6 divided by x2 minus x1 is 10 minus 2. So when I tidy that up, I get negative 6 divided by 12. I need to break that fraction down because it's got to be in its simplest form. So 6 divides into both. So 6 into 6 goes once, 6 into 12 goes twice. So the gradient of PQ is minus a half. Now, we must, and if you don't write this down, you do not get your mark. We've got to state that for perpendicular lines, okay, so perpendicular lines, we know that M1 times M2 is equal to minus 1. You write that down and you put a wee cloud around it, and if you do that, then you can state the gradient of the perpendicular line. So gradient, and I'll put in a wee perpendicular sign, that's equal to, we want to flip that, so it's 2 over 1. I don't want the negative, I'm changing sign, so 2 over 1 just becomes 2. So that's the gradient. I know a point in the line, so that's me, I'm ready to do the equation. So keep organised, make sure your work is all really clearly set out. So I'm going to write down equation of perpendicular bisector. Just going to abbreviate it to perpis. Underline it, gather your information. It's the equation of a straight line, so I need to know its gradient. So the gradient was 2, and I need to know 1 point on the line, and if I go back up there, I can see that the point on the perpendicular bisector was 4, 3. So once I've done that, I'm using y minus b is equal to m times x minus a. That becomes a and b. So therefore, y minus b is y minus 3 is equal to 2 times x minus a, which is x minus 4. So y minus 3 is equal to 2x minus 8. We want to get that y equal to, so we're going to add 3 onto both sides. So y is equal to 2x, and when I add 3 onto that side, that's going to be negative 8 plus 3, so it's going to be negative 5. And that's the equation of your perpendicular bisector. You should always underline your answers so that it's clearly written out. Double line your final answer. This next question is from the past paper 2023 paper 2. So you do have access to a calculator if you need it, but usually questions like this, you don't really need your calculator. Right, so we've got question number 1 is for 5 marks. Triangle PQR has vertices P is 5 minus 1, Q is minus 2, 8, and R is 0.13, 3. It says find the equation of the altitude from P. First thing I'm going to do is I'm going to write these coordinates in. So P is the point 5 minus 1, Q is the point minus 2, 8, and R is the point 13, 3. Now I'm going to do a wee check and make sure I've copied them down properly. So P is 5 minus 1, Q is minus 2, 8, and R is 13, 3. It takes a couple of seconds to do that. It's really important we don't make any mistakes. So we want to find the equation of the altitude from P. So there's the equation, there's the line, the altitude is coming from P. The definition is for an altitude, we'll put a wee LT in there for altitude, it meets the opposite side at 90. When you take an altitude, it's like taking your height. If you're measuring your height, you stand perpendicular to the floor. So an altitude is a line, it's not a height. An altitude is a line that comes from a vertex and it meets the opposite side at 90 degrees. Now, for an altitude, we only know one point. I only know point P. So I've got to find out how can I get the gradient. I don't know 2 points on it, so I can't do the gradient using y2 minus y1 divided by x2 minus x1. But I do know it's perpendicular to QR. So I can work out the gradient of QR and flip it and change the sign. So you start off and you do MQR, and again that's y2 minus y1 divided by x2 minus x1. Okay, and in an exam you will label all those points. Okay, so we'll call that point 1, so that's x1, that's y1, that there will be x2, and that will be y2. So y2 minus y1 is going to be 3 minus 8 divided by x2 minus x1 is going to be 13 minus 2. So when I work that out, I get minus 5 divided by, that's going to be 13 plus 2 is 15. Double check your numbers. It only takes a second and it's really important to get them right. So 5 divides into both of them. So 5 into 5 goes once and 5 into 15 goes 3 times. So the gradient of QR, so the slope, the measure of the slope of QR is minus a third. Now we know that the altitude, the gradient, we flip and we change the sign. But before we flip and change the sign, we've got to write down some sort of a wee formula. So M, it's not PQ, it's MQR. So MQR multiplied by the gradient of the altitude is equal to -1. You could get away with doing M1 times M2 equals -1 as long as it's stated. Now if you state that, then you can go on and write down the gradient of the altitude, and I'm going to say perpendicular gradient, and perpendicular sign. Flip that, becomes 3 over 1, change the sign, it's positive, so the gradient becomes 3. So now I want the equation. So we do a wee subheading equation of altitude. Underline it. Okay, so gather all the information that I need to get the equation of this altitude. It's the equation of a straight line, same as National 5. You need a gradient and you need a point. So the gradient I've worked out is 3. The point, and the only point that I know on the altitude, there's the altitude there, is this point P. You'll only ever know one point on an altitude, and the coordinates are 5, -1. And we're back to our normal formula, y minus b is equal to m times x minus a. We're now going to sub that in. So y minus b, so remember that is a, and that there will be b. So y minus b is y minus -1, and that's equal to 3 times x minus 5. So we know that that is y plus 1. That's equal to 3x's minus 15. I don't want that plus 1 to be there, so I'm going to take 1 away from both sides. So y is equal to 3x's minus 16. And that's the equation of the altitude from P. So that's 3 marks for that one. Part B. Part B is calculate the angle that the side PR makes with the positive direction of the x-axis. The same thing again, the positive direction of the x-axis. That's code for writing down gradient is equal to tan theta. Now I want to work out the angle, so I'll just switch it around. So tan theta is equal to the gradient. Now the gradient of what? Back to the question. It's the gradient of PR. So we'll work out the gradient of PR. So P was the point 5 minus 1, and R was the point, and I'll flick back to see it. You will be able to see the question when you're doing this on your paper because you'll have it in front of you. So it's 13.3 for R. Okay, so 13.3. Right, so we're going to do the gradient formula. which you will do loads of times. So gradient is y2 minus y1 divided by x2 minus x1. Label your points and then fill them in. So y2 is 3 minus 1 divided by 13 minus 5. So 3 minus 1 is 4 divided by 13 take away 5, and 13 take away 5 is 8. Break it down. So 4 into 4 goes once, 4 into 8 goes twice. So the gradient is a half. So what we've now got then is we've got tan theta. So tan of this angle is equal to a half. I don't want tan to be there, so I'm going to shift that tan away. So theta is tan to the minus 1. So that's me shifting the tan away of a half. So on your calculator, as a calculator paper, and this is not an exact value one, so you do shift tan and put in your half or 0.5, and when you do that you get 26.6 degrees, and that's that one all done. Okay, we're now on to 2022 paper 1, so non-calculator again. Question 1, so straight line is one of the first questions that you get asked. So this one, it says determine the equation of the line perpendicular to passing through the point. So we've got a line that's perpendicular to that one. So we need to find out what the gradient of that one is, but it's not in the correct format. So we've got 5x plus 2y is equal to 7. So we want to take 5x off both sides. Always write your x's first, so it's minus 5x's, and we'll leave the plus 7 at the end. We don't want 2y, so we're going to divide it all by 2. So y is equal to minus 5 over 2x plus 7 over 2. So therefore, the gradient of that line is equal to the actual number, the coefficient of x, the number in front of x, which is minus 5 over 2. So the equation of this line that we want, okay, so we want the equation of that line that is perpendicular to that one. So to find the gradient of the perpendicular line, we've got to flip and change. So gradient of perpendicular line, flip it and change the sign, so it becomes 2 over 5. You must write down m1 times m2 is equal to minus 1 and put a wee cloud round it. So now we've got the gradient. So the gradient is equal to 2/5, and the point that it passes through, they've told me, determine the equation of the line perpendicular to, passing through minus 1, 6. So that's all the information I need to get the equation of that line. I'll just label that A and B. And we've got y minus b is equal to m times x minus a. So y minus b, whoops, I'm just going off the end of that pad. So y minus b is equal to m times x minus a. Right, so y minus b is y minus 6, and that's equal to 2/5 times x minus a. So it's x minus 1, so it's x plus 1. Now, don't like fractional gradients, so I'm going to multiply it all by 5. So y times 5, 5y. 6 times 5 is 30. When I multiply all of that by 5, the 5 disappears at the bottom, and it gives me that. And I'll now do the bracket. You can do that in one step if you want, but just be careful, you don't want to make mistakes. So that's 2x's plus 2. So nearly there. All I have to do is get rid of that minus 30. So we'll add 30 to both sides. So 5y is 2x's plus 32. Now, there is no need for you to change that to 1y equal to anything. That's perfectly adequate to leave it as that. As long as you've got a y term, one x term, and one number. As long as it's all simplified, then that is okay. That's it, all done. This one, it's a straight line question, but it's got a wee bit in it that you've not done yet, so I'm going to tell you what that wee bit is. But it's from the 2022 paper, and it's from the paper 1. So it says a line makes an angle of pi by 3 radians with the x-axis and passes through the point minus 2, 0. But you don't know what that is, so I'm going to tell you what it is. So pi by 3 radians, I'm going to change that to degrees. You'll be able to do it later on when you've done the topic on it, but right now all you have to know that that is equal to 60 degrees. So that angle in there is 60 degrees. Now, we want to find the equation of the line. I need to get the gradient. So there's the line there. To get the gradient, I'm going to look at the x-axis. There's the x-axis there. And I want to find the angle between the x-axis and the actual straight line. So it's that angle in there I want to know. So we've got a wee bit of easy angles to do beforehand. That bit there, that's your x and y axis, so that's a right angle. There's a pair of x angles, so that's got to be 60 as well. But I really want that one. So 180, take away 60, take away 90, and that angle is 30 degrees. So I know the angle that the line makes with the positive direction of the x-axis. So therefore, I know gradient is equal to tan 30. So I can work out what the gradient is. This is a paper one, non-calculator. You're using your exact values. So what you want to do is you want to look at the exact values that you've got on the front of your information sheet. And if you do that, you'll find out that it's 1 over root 3. So the gradient is 1 over root 3. So we want the equation of this line. I've got the gradient. So to get the equation, a wee subheading. And gradient is equal to 1 over root 3. And a point on the line, they've told me that it passes through the point -2, 0. So -2, we're back to y minus b is equal to m times x minus a. You will do that hundreds of times. So y minus b is y minus 0 is equal to 1 over root 3 times x minus a. So it's minus 2, so it's x plus 2. So if we tidy that up, y minus 0 just stays as y, and that's equal to, multiply this bracket out, 1 over root 3 times x is 1 over root 3x, and 1 over root 3 times 2, multiply straight across the top, straight across the bottom. Remember, that's equivalent to a 1 at the bottom. So 1 times 2 is 2, and it's only a root 3 at the bottom, and that's the equation of that straight line. That's you all done. Double underline your final answer. So that's worth 3 marks, and that was it. Okay, we're nearly getting to the end of this. So it says, first of all, it's from past paper 2021, paper 2. So you're allowed a calculator. It's 7 marks in total, and it's a pretty routine straight line question. Triangle ABC, they've drawn it down for us, a wee rough version of it. And for part A, it says the line L1 is the altitude through B. So they're calling it L1. So just trying to make it easier rather than saying the altitude through B. They're giving it a label. So what we've got then for this is, we've got the altitude through B. So the altitude through B, an altitude is a line that comes from a vertex and it meets the opposite side inside the triangle at 90 degrees. That's a wee 90 degrees sign. And that's your altitude from B. Now, we know B is the point 3,1. I'll write these in. C is the point 4, -5. And A is the point -5, 1. So, I only know one point in that altitude. I know point B. So I can't work out the gradient using y2 minus y1 divided by x2 minus x1. So I need another way of getting the gradient. You work out the gradient of AC. It's perpendicular to that. Flip and change the sign. So we start off gradient of AC. And gradient of AC, we know the 2 points, so it's y2 minus y1 divided by x2 minus x1. So we'll label the points. That would be x1, that will be y1, that will be x2, and that will be y2. So y2 minus y1 is -5, take away 1, divided by x2 minus x1 is 4 minus -5. So when I work that out, I get -6. Wait a minute. So when we get the gradient of AC, we've now got to work out the gradient of the altitude. So we write down m1 times m2 is equal to -1. And if we do that, we can flip and change the sign. So therefore the gradient of the altitude, that's a perpendicular gradient, is equal to, if that's minus 6, it's minus, it becomes positive, and it becomes 1 over 6. So now we've got the equation to do, and to do the equation, I'll move this down a wee bit. So still part A. So the equation, we know that the gradient of the altitude is equal to 1/6. And I know one point on the altitude, so we look back there, the only point in altitude is the one that it's coming from, which is through B. So B is the 0.31. So therefore, back to y minus b is equal to m times x minus a. So that would be y minus 1 is equal to 1/6 times x minus 3, multiplied by 6, 6y minus 6 is equal to 1 mod of x minus 3, which is just x minus 3. And we'll finish it off by saying 6y is equal to x. We want to add 6 on both sides, so it's x plus 3. So that's the equation of line L1, and that's the altitude through B. So the next thing we've got to do for part B is we have got to find the equation of the line L2, which is the perpendicular bisector of AB. So we want the perpendicular bisector of AB. Now what I'm going to do is I'm just going to draw the line for the line, and then we'll draw the perpendicular bisector on it. So perpendicular bisector of AB. So that's the point A, that's the point B, and we'll stick some coordinates into this. So A is the point minus 5, 1. So minus 5, 1. And B is the point, flick back up there, the point 3, 1. Okay, so perpendicular bisector is a line that cuts that right in the middle, and it cuts at right angles. Okay, so if you want to work out the gradient of AB, do your y2 minus y1 divided by x2 minus x1. So it's 1 minus 1 divided by 3 minus minus 5 is 3 plus 5. So 1 minus 1 is 0, so 0 divided by 8 is still 0. Now, I did spot that, okay, but I'm going through the working with you because that coordinate there is exactly the same as that one. So the equation of that line is y is equal to 1. Okay, so that line is perpendicular to the y-axis and it's parallel to the x-axis. So that means it's got a gradient of 0. So the line that's perpendicular to that has got a gradient that is undefined. So the perpendicular gradient is a gradient that's undefined. Now, gradient undefined means it's so steep that you can't measure it, you can't put a number on it. So that means that it's going to have an equation, x is equal to a number. So all we have to do is get the point, and that'll be the midpoint, and then that'll tell us what the x number is. So add minus 5 and 3, so that's minus 2. Minus 2 divided by 2 is minus 1. And 1 plus 1 is 2. 2 divided by 2 is 1. So I know x is equal to a number. So what is that number for x? It's minus 1. And that gives you the equation of that one. So that get cut down a wee bit because you didn't need to do all of your normal work. Those ones should be easier, but sometimes turn out to be harder if you don't spot these things. So the last thing, determine coordinates of the point of intersection of the line L1 and L2. Now there's only one mark for that. To find where two straight lines cross, you solve simultaneous equations. But for this one, the two equations are x is equal to minus 1, and the other equation is 6y is equal to x plus 3. Half that equation has been done for you. That's why it's only worth 1 mark. The simultaneous equation has been done to find x. So we sub x equal to minus 1 into that equation there. So we've got 6y is equal to x, which is minus 1 plus 3. So 6y is equal to 2. So y is equal to 2 divided by 6. And 2 divided by 6 is equal to 1 divided by 3. So your point of intersection is minus 1, 1/3. So pretty standard question, okay, so go through them and learn all of them.